A very good afternoon, all present. I, Dr. Vij Kumar, presenting a paper. My paper ID is 8194 and title is AI-enabled face detection approach and comparison with the PCA technique. Now presenting my paper. Introduction. Face recognition and detection has become an important research area in computer vision due to its numerous applications in various domains such as security, biometrics, and the law enforcement. Face recognition involves identifying or the verifying an individual's identity from digital image or a video frame. The process of the face recognition typically involves three main stages: face detection, feature extraction, and classification. In recent years, machine learning has emerged as a powerful tool for face recognition, enabling and development accurate and efficient algorithms. In this paper, we review the literature on face recognition and detection using machine learning and discuss the methods, techniques, and applications. Now, next slide. Face detection. The first stage of the face recognition is face detection, which involves locating and isolating the face region in an image or video frame. Various techniques have been proposed for face detection, including template matching, Vilo Jones algorithm, and deep learning based methods. Templates matching involves comparing of the template face with the target image and identifying regions that have high similarity. The Vilo Jones algorithm is a classic approach that uses a cascade of the simple classified and identity faces. Deep learning-based methods such as the convolutional neural network (CNN) have shown superior performance in the face detection during their ability to learn features directly from the raw image data. Now, feature extraction. After the face region is detected, the next step is the feature extraction. The goal of the feature extraction is to obtain compact and the discriminative representation of the face, which can be used for the classification. There are several feature extraction techniques such as the eigenfaces, facial faces, and the local boundary patterns (LBP). Eigenfaces are based on the principal component analysis (PCA) and involve projecting the face images onto the lower dimensional space where the most important features are preserved. The feature faces are an extension of the eigenfaces, which incorporates class information into the feature space. LBP is a texture-based method that encodes local image patterns and has been shown to be effective in face recognition. Now, classification. The final stage in face recognition is classification, which involves assigning a label to input image. Classification can be performed using various machine learning algorithms such as support vector machines, SVM, nearest neighbor, KNN, and neural networks, NN. SVM is a popular method for classification, which involves finding a hyperplane that separates different classes with the largest margin. KNN is a simple yet effective algorithm that assigns a label based on the majority classes of the k nearest neighbors in the feature space. NNs are the powerful neural network machine learning algorithms that can learn complex non-linear mapping between the inputs and the outputs. A PCA technique, principal component analysis, and the PCA face location is the one of the most famous and the testing obligations of the PC component circumstances. It is among the most fundamental achievements that might be done utilizing this methodology that was at first made by the Shevrovich and the Kirby in 1987, and Turk and Alex uh, Pentland involves it without precedent for the face type in 1991 that is easy to implement, and subsequently it utilized in many early face acknowledgement bundles inside the cutting edge work. Yet it has a couple of the risks. Likewise, for example, this calculation requires the edited face pictures with right gentle and the model for the tutoring. In this examination, we will essentially be talking about the roughly about the execution of the technique in Python in the skit-learn. Now, this is a flow chart on the PCA performing face techniques. So the first phase is the acquiring of the new image from the camera, then convert color to the grayscale. Second stage, after detection of the faces, here is a cascade classifier applied, and here is a decision making whether detected face or not. If detected, it goes yes, detects eyes in face images. Then again cascade classifier. If yes, then two eyes detected. Yes. If no, then again going back to detect faces. Here again in the face detected. If no, then again go to the face detection phases, and this loop is repeated. If single eye detected, then again go to the face detection phases. So two eyes is essential. If both eyes are detected, then normalize the face images, size and orientation, contrast and lightening enhancement, then facial recognition. Here is a PCA classifier applied, and here is a recognition training. So face samples collections, thereafter recognition training, and then PCA classifier. So now this way we make a template and store in the database. These are the formula of the training data set. Here is a suppose an image. Here is a n square into one vector. Now result and analysis. Face value collections with this complicated heritage of the PCA and its huge head scale version. Minor version is a head flip, tilt, slant, and expression. Some transition with the face roll of the values, and substantial light variation due to the item movement. In the artificial mild, in the record sets, the face series values have a undeniable history. In a small head scale version, a larger scale version like a head flip, tilt, and slant, and the most significant version is the expression. The face collection has complicated history, a large head scale variation, a major minor version is a head flip, tilt, and the slant, and expression that is a few translation of the face roll and significant mild version. As a result of item 2, in the result, the measurement set face series values with the evident legacy and a little held scale variety, critical rendition in the head turn, slant, incline, and most significant variation, the minor having a minor interpretation of the face position and light variations. In a statistics set, the face series with the steady heritage having a minor header scale variance and the light versions, and additionally massive variant in the flip, slant, and the expression and its face function. Now conclusion, face recognition or acknowledgement is a difficult and a fundamental standing strategy in current period. Finally, we have got provided a reality that having an intelligence that would merge exercise from the sufficiently effective reinforcement, gaining knowledge of person that understand to maximize the coming reward, assuming its variable, and it gives a quick pathway towards the examining and assembling a fake most recent insight. Now conclusion continued. Face recognition detection is the process of the identifying or the verifying an individual's identity from a digital image or the video frame. Machine learning has emerged as a powerful tool for the face recognition and detection, enabling the development of the accurate and efficient algorithms The process of the face recognition typically involves three main stages: face detection, feature extraction, and classification. Various tactics have been proposed for the face detection, including template matching, Boyle-Jones algorithm, and the deep learning based method. After the face region is detected, the next step is feature extraction, and there is a several feature extraction techniques such as the eigenfaces, facial faces, and the local boundary pattern (LBP). The final step of the face recognition is the classification, which involves assigning a label to the input face images. Classification can be performed using the various machine learning algorithms such as the support vector machine (SVM), K nearest neighbor (KNN), and the neural network (NN). Now comparison with the PC. Five datasets have been used for the following above experiments. In the dataset, the face series values with its various undeniable inexperienced foundation having no header scale, light variety, yet having no very many changes in the head turn, slant, incline position of the face, and the huge exchange in the given evidences. In the second data set of the statistic unit, the face collection of the values with its crimson specific history variance as a result of the shadow as the cursor move forward and having minimal changes, tilt, slant, and wide. So the third place of the data set records set of the given data set is defined. Now complexity evaluation. In the present scenario, gadget, the HAR-like capability suggested enormously well, but it has a great deal fake recognition that the LBP that will that will recall being the goal work in surveillance to the understand fails fast detection having the HAR-like capability and an experimental evaluation and also popularly elements Gabber that is mentioned well in the characteristic and it will be overcome the dataset complexity. These are the PC and dotted graph depicting the training dataset using PC. Now wide variety of the occurrences of the image in pixels, range occurrences of the snapshots, graph chart, and challenge of the future directions. Despite of the progress made in the recognition and detection using the machine learning, there are several challenges that remains to be addressed. One of the main challenges is the issue bias and fairness. As face recognition system has been shown to have a higher error rates and certain demographic groups. These are the references and that are collected. Okay, thank you.